Good morning, class. Today we're going to be continuing our lesson on the rock cycle. We're going to focus on sedimentary rock as well as weathering. And you'll see how those two go together in a second here. Sedimentary rock comes from the buildup of sediments, which is what we went over yesterday or on Wednesday. But where do the sediments come from? So today we're going to focus on how these sediments build up and where the sediments come from. So when I talk about sediments, we're looking at dust, dirt, sand, kind of all the grainy bits that you'd find like the bottom of a lake, in your backyard, bottom of the ocean. And most of these sediments, say like 99.5% of these sediments, comes from the breakdown of rock due to weathering. So we talked about weathering a little bit before when we talked about how mountain ranges can shrink. So we're going to get a bit more into the finer details of weathering here. So as rocks break down due to weathering, small pieces break off. So if we have an igneous, metamorphic, or even a sedimentary rock, these rocks are going to break down and shrink in size. And the parts of these rocks that break off are going to form sediments, and they're going to form into sedimentary rock. So the weathering process is the start of the transition from an igneous, metamorphic, or even a previous sedimentary rock into a new sedimentary rock. As these rocks get broken down and the sediments move into a body of water, they get compressed, and that compression over time forms a new rock. Okay, so let's look at how this weathering process happens. So there's three main types of this weathering process: physical, chemical, and biological. So we'll start with the physical weathering, and this mainly covers the effects of temperature on rock. So you think, well, that must be a pretty small effect because doesn't get that hot around the rocks. Maybe if you're in the sun, a rock's going to be maybe 60 degrees Celsius if it's really baking in the sun, and you get cold, get to like 4 degrees Celsius. That's not too big of a temperature change in the grand scheme of rocks and the temperature at the center of the earth, where it's like a couple thousand degrees Celsius. But what happens is when rocks heat up, even the small change in heat, the rock is actually going to expand. Very little, but it will expand. So the expansion comes from as atoms heat up, they gain energy and they want to take up more space. So they move around more. It's kind of like how like a gas takes up more space because the atoms have more energy than a liquid. So as the atoms want to take up more space, they push away and the rock expands ever so slightly. And this happens mainly on the surface where the rocks are like baking in the sun. And as these rocks expand, the top layer can just like break off. So if you find like sheets of flat, thin rock, it could be up to the size like a table. That's generally going to be broken off of the main rock it was attached to because of the effects of temperature or physical weathering. So I'm going to try to add some pictures of the weathering process for you in a separate document. So you can have a look at that as well. So the weathering due to heat or due to the rocks heating up, we call this exfoliation weathering. And this generally happens mainly when the rock is exposed to straight sunlight and there's not much dirt, sand, or plants around. It's just kind of like a sheer rock. So there's a second type of weathering that has to do when things get colder instead of hotter. So if it's kind of wet outside, some of that water is going to seep into the rock, even just a small amount, but it'll kind of seep into the rock and the rock will have a little bit of water inside of it. And if the temperature falls below freezing, this water is also going to freeze. And when water freezes, it's actually a rare, well, an uncommon compound that when it freezes, it takes up more space. So when water freezes, it's going to take up more space, and that expansion actually causes a lot of pressure in the rock, and that can form cracks in the rock as well. So these cracks go deeper into the rock, so they can be from like the center of the rock. Um, and this is also why in colder places, especially in Canada, the roads are so bad because water seeps into the roads and then it freezes and it expands and breaks up the roads. So we don't really have that problem in Victoria because it doesn't get cold enough to really break up the roads. But in more interior Canada, it's a big problem with some of the roads. So we call this type of weathering the freeze and thaw weathering. So that covers physical weathering, which is both sides of the temperature range, hot and cold. Next, we'll look at chemical weathering. So chemical weathering covers the effects of water. You may think, well, why do we call it chemical weathering, not water weathering? It's really the chemicals that are in the water that break down the rock. They cause weathering on the rock. So it's the compounds or chemicals that are in rainwater that's going to react with the compounds and chemicals in the rocks. So there's three types of chemical weathering that we're going to look at here. First type, or maybe before I start on the types, I'll look at what is rainwater and why does it have chemicals in it. So even just water by itself, we're going to call that a chemical as well. It's H2O, so it's hydrogen and two hydrogens and one oxygen element. But then also, rainwater is considered an acid. This is due to water droplets when they're in the clouds or in the atmosphere. They're going to pick up some of the pollution that's in the air. So they're going to absorb some of the chemicals. For a basic example would be CO2. So there's a bunch of CO2 in the air, and water is going to absorb this CO2, and it's going to become slightly acidic. So you're going to have an acid to it, which is acids are really good at eating away at compounds. So just a side note on this rainwater, or what we call acid rain. The pollution in the air, that's what gives water or rain its smell. So when you like go outside, oh, it smells so fresh. So like, oh, what's the word? It smells like nature when you get like fresh rainwater. It's actually the pollution in the air that you're smelling. Now, even without humans, we still have pollution in the air. So it's not just human caused. Before humans, there's still CO2 in the air. However, humans have accelerated the process of acid rain, made it more acidic, and put compounds in there that aren't as natural as CO2. Okay, so looking at the pollutions in the water, most of this happens due to CO2, but it also can happen to some of the other compounds that humans have been putting into the atmosphere. But the pollution in the water lands on the rock, and it's going to actually dissolve away the rock. So very small pieces of rock are going to break off because they get dissolved into water, and they're going to get carried away with the water. So as the water hits the rock, it's going to pick up some of the top little bits of rock, and it's going to kind of dissolve them. So it's going to break them down into even smaller parts until you can't even see them with your eye. And then they're going to get carried away as the rainwater washes off. So this effect happens over time. It's not like you just put water on a rock and you can see like a big hole in the rock. But over time, you can see, if you look at one of the pictures that I added for, we call this the solution weathering, you can see that over time as water moves through, you can see like lines where the water is always going through. So it happens over a bunch of cycles of water pouring down the rock. So again, when it's due to the pollution, the acid in the rain eating away at the rock, we call this solution weathering. So acid rain also reacts with the minerals in some of the rocks, and this changes the structure of the rock and forms it into a clay compound. So a clay compound is much softer, and it absorbs more water and it reacts with water much more aggressively than just plain rock would. And we call this hydrolysis. Hydrolysis? Hydrolysis. I think hydrolysis is right. Weathering. So we call this hydrolysis weathering. The third part of chemical weathering is when oxygen in the water, so this is nothing about pollution in the air, but with oxygen in the water, so when say water is H2O, so the O part of the water for oxygen can also break down some rocks. So rocks will contain different types of minerals in them, and most rocks will have some sort of metal component to them, like iron. So this iron, if it comes in contact with water, the oxygen actually rusts the iron, and it changes the structure of the iron, and it becomes rust. And this is called oxidation. So we call this type of chemical weathering oxidation weathering, where the oxygen in the water actually breaks down some rocks as well. The third main type of weathering is biological weathering. This one's maybe the most interesting, and I plan to have a small project for you to do on biological weathering. But biological weathering covers the effects of living organisms, such as plants, bacteria, animals, and even humans, on rocks or the environment. So I was thinking about this as I was reading, and I don't have a good answer. I will find an answer for you. But I was thinking, I wonder if when we're digging, like let's say, or making a train track, and we're blowing up sides of mountains, destroying rocks, making a tunnel in the rocks, is that considered weathering? Is that considered something else? Um, I don't know. I'll look it up, so I'll have an answer for you maybe on Tuesday's video call. But have a think about that. I'm curious to see what people think. So one of the main notes I want to make about weathering, that it happens very slowly. So it's not a fast reaction where things just all of a sudden the rock is disintegrated into sediments. Over time, these rocks break down into sediments, which form sedimentary rock. But 90% of weathering, you won't see the effects day to day, maybe year to year. It'll take tens to hundreds of years to see the effects of weathering. So that's the end of lesson 4. So this is coming out on Friday. So I have 4 questions for you. The first question, I want you to explain your answer. So even if your answer is not right, I still need to see you explain your idea, which is very important to explain them. This weekend, I'm going to go through and mark the work you've submitted so far, and I'll try to give feedback on some questions that you didn't get necessarily right. So look for some feedback maybe on Monday. Hope you have a good weekend. I'll see you all on Tuesday.